and I'm going to offer some of the homework problems from 6.1 and 6.2. I'll do a bit more than the ones that are just special problems, because I want to show you all the various things that we can do here. Well, the first one here is, so in number 17, this is the series they give us, and be careful, what they're asking here is the interval of convergence as well as the radius of convergence. So be very careful to read the questions, what they ask. Sometimes it's just the radius of convergence, but sometimes it's more. And I'll show you what that means here. So we know that with a power series like this, we always have to do the ratio test. So to calculate the radius of convergence. So that is this rho here, that is, I'm going to write again up what it means. That's what the ratio test asks us to do, right? And so in this case, there are absolute values and they're absolutely necessary. Okay, sorry for the pun. And here is the formula, and instead, on top we have now the same, but replace n by n plus 1 everywhere. I hope that's clear what that I just did that. Okay. Then, what about these absolute value signs? Whatever there are signs that are obviously there, we ignore them. There are none, but there's also this hidden sign in x, and so we have to keep writing absolute value of x here. Okay. So, oh, by the way, I should have said that right from the beginning. The center here is 0. It's always good to actually first figure out what the center is. Okay. So, in this fraction, we have on top this n plus 1 square, this x to the absolute value of x to the power n plus 1. And then this 2 to the n will also be on top. And then in the bottom we get this 2n plus 1, the absolute value of x to the power n, and then the n square. The powers, these exponentials here, we can always simplify. The highest exponential is in the bottom, so we get a 2. And this always has to be like this. We have to get something involving x in the top here. Okay, so far so good. Now, what are we left with? It is to see what you're doing. Do not expand things too much. In particular, take out whatever factors you have that do not depend on n. And I'm referring here to this x and this 2 here. So let's take that out already. And then what is left is this limit here. And there are many ways of doing it, but as I said, my preferred way is actually combining them in a single square, and then take the limit of the inside part. Now, I hope that everybody sees that the limit of the inside part is 1. Okay, I'll do it very quickly, but I'll do it almost without words. So we get here x over 2 limit n going to infinity. And so I get 1 plus 1 over n, and then this whole thing squared. Remember, take the limit inside. And then that gives me absolute value of x divided by 2. And this whole thing, of course, because this is 0, goes to 0, we get just 1 here, times 1, but I'm not going to write that anymore. And then don't forget, there is a condition now. We're doing the ratio test, and the ratio test tells us if this row is less than 1, then we have convergence. Okay? So now, the radius of convergence. How do you find the radius of convergence? Be very careful to not say, oh, it's 1. No, you have to solve for absolute value of x in this inequality. So that becomes absolute value of x is less than 2. And then this number is your radius of convergence. So I'll go back to black. R here, the radius of convergence is 2. Now, I prefer to, now we have to do the interval of convergence. That's now the next question. Well, we'll start with figuring out what are the possibilities. Where is it actually? What could it be? Well, you always plot the center first. C is 0 here, the center. And then the radius tells me I can go 2 units this way or 2 units that way. So I would be here at 2, and here I would be at -2. And that is the interval of convergence. Inside we have convergence, so the convergence green, right? So this is going to be all convergent. Everything outside is divergent, okay? And the only thing that's left is what we do not know yet is what's happening in these 2 points. And how do we figure that out? Well, we look at the series where we replace x by these 2 endpoints, the values of these endpoints. So my series here was some x, so we had summation n square. The x now is -2 to the power n, and in the bottom we had a 2 to the power n. And then it's always very good to separate your sign from everything else. So here, because we have here a power of -2 to the n, but we can split that as a -1 to the power n and 2 to the power n. Okay? And in the bottom we have 2 to the n. And what always, typically for this kind of endpoints, is that we have good cancellation here. Did I do this all correct? Yes. So this is what we get. Oh, an alternating series, so we have to take at the limit of what happens at so the alternating series test, although you don't need to do this actually here, you can do quicker, but the limit for n going to infinity, ignore the sign, and so you're only left with n squared, well, that's infinity, which is of course much bigger than it's not 0, sorry, alternating series test, it's 0 or otherwise divergent, so this is divergent. So what happens at x is 2? Well, we now plug in the same thing, but instead of -2, we plug in 2. Go back to see that this is what I'm doing here. Again, get cancellation. What's the sum of n squares? There are many ways of seeing this, that is divergent. One way is take the limit, which we did already, and we see the limit is not 0. That's the divergence test. Another way of seeing is that this is a p-series. Yeah, but wait, p is 2, that's bigger than 1. No, what is p here? P is -2, right? If I have to write this as in the form of a p-series, then I would write this, and p is -2. So that would also tell me divergence. Same conclusion. So what does this mean? Is that neither point is part of it. So they're both open here. If you denote it that way, it's fine. Sometimes one denotes this with an interval notation. So we say it's the interval, so the solution, or the domain if you want, or the interval of convergence, let me call it that. Let me write it here then. The interval of convergence, that is in this case from -2 to 2, with these parentheses meaning not included endpoints. And if we would include it, we would take square brackets, right? Okay. Okay, that was one of the problems. What else? From 6.1, this was not assigned, but I want to do it now. No, I'll do it later. Let me go to 6.2, the other assignment. 97. Question number 97. Okay, let me bring that up. Sorry, I have to. 97. So we had the ln of 1 minus x squared, and we needed the center 0. We said in this kind of problems, we're always going to take the center equal to 0. The book, it says at x equals 0, they mean centered at 0. Okay, and so what we need to do here, so how do we do this? It asks for us to give they say find the power series for this thing, and the way that it is formulated is a little bit. So what does it mean here? Now this is not an easy exercise, and I promise you that if on the test or something, I will give you a few hints. So why is this not so easy? Well, we only really have this one that we discussed this in the previous video. We have 1 plus x squared plus x cubed. That was the geometric series, and that was if absolute value of x is less than 1, which means that the radius of convergence was 1. Okay. Now, ln minus 1x squared is not really the same thing. And in fact, I cannot immediately get from here to there. I have to do an intermediate step, and that is perhaps the difficulty with this kind of questions. And on a test, on a quiz or something like that, I will help you. So what I would say is, first, well, before you find this thing, find a series for this guy. Now, why can I even do that? Because if you think about it, if I take derivative of this guy, I get this one. So put differently, taking antiderivatives gives me this. Well, I have to be perhaps a little bit careful with the negative sign. I'll think about that later. But for now, I'm going to just do that. So let's antiderive. So the conclusion is, I do this in different color here. I'm going to antiderive this side, and I'm going to do this here, antiderive. Both sides. Because they are the same, anyway, as functions they are the same, well, provided this is true. But by antideriving, we don't change that condition. Okay, so the antiderivative of n minus xx, what is that? Well, that is ln 1 minus x. That's the antiderivative of 1 over x is ln x. But now I have to think a little bit. If I take derivative of ln 1 minus x, what do I get? I get 1 over 1 minus x times the derivative of the inside function, which is unfortunately negative 1. So there's an extra negative 1 here that I have to put to compensate. Okay, so understand this is compensation compensate for the chain rule. If I would take the derivative of this expression, I will now get what I want. That's what antiderivatives need to do. Okay. Good, and then what happens here? Well, that's very term by term. Antiderivative of 1 is x, antiderivative of x is x squared over 2. This is all the power rule. Plus so, and I'll do one more, x to the 4th over 4 plus dot dot dot. Well, anyway, plus c. There's a constant that I don't know. How do I know what the constant is? We said, well, you always now look, so how to determine this, right? What is this c here? Plug in the center. In this case, that's x equals 0. Let's do that. I'll do it in another color that you see what happens. So I'm going to plug in 0 in here. So I get minus ln of 1 minus 0 equals, and I'll plug in 0 there. Oh, but all these guys are gone, right? So I get to c. Now what is ln of 1? That's 0. Well, negative 0 is still 0, right? So actually c was 0, yes. So now I know that c is 0. Allow me to therefore say, okay, there was no c here. Why did we do this? Well, from here, now that I have this guy, or the negative of that guy, I can go to this guy by replacing x by x squared. So now I'm going to replace x by x squared. And I have to do this everywhere. So let me do this again. But I want to take care of the negative sign first. So I'm sorry a little bit. This is what I can do, right? I can erase a lot of stuff. So I'm going to get rid of all these things. I have now explained all that, so I can get rid of this. This well, and we know there is no c, so I'll get rid of that too. And then I'm going to just fudge my sign here. I'm going to put the sign here, and I'm going to make signs, negative signs everywhere. And then this becomes a positive sign. Okay? So this, everything is negative. And distribute the negative sign on the left-hand side. From the left-hand side to the left. Okay, so now I see that to get this one, what I need to do is substitute x by x squared. So let's do this again in a different color. I use this one. So what I'm going to do here is replace x by x squared. And the same, of course, on the other side. But I should keep also, sorry, I should have done that. Copy down here. When we antiderive, we said this doesn't change. But now, of course, we're going to plug something in, so things might change. That was orange, right? So I get ln of 1 minus x squared, replace x by x squared. Now you do this here too. So this becomes minus x squared. What happens if I plug in x squared here? X squared squared, that is x to the 4th. I put in x squared to the power 3, that is x to the 6th. And the next one, x to the 8th, right? 4 plus dot dot dot. And this is if the absolute value of x squared is less than 1. Replace x by x squared. Now, luckily, this actually doesn't mean, well, luckily, I don't know, it doesn't change anything, because this is just x squared less than 1, and we take square roots, and we find that absolute value of x is less than 1. So this particular substitution did not change the radius of convergence, but other might. okay? And so be aware of that. Okay, so that was question number 97. So these were the two assigned questions. I want to do one other one that was not assigned, was an optional one, but I left it optional because, again, without help, it's something you're not going to figure out, perhaps. Well, it was asking for, so number 99, can we find a series for arctangent of x squared? How on earth do we get from, remember, we always, in this particular topic, in 6.2, we always start from this, well, from this guy. It's always from there that we start. How are we going to get on earth from there to there? Okay, I need to show you the steps in between. So the first step, so step 1. So I'm writing the steps, but I will tell you I will tell you what to do on a quiz. I will give you the hints for what steps to do, but of course you still have to carry out the step, but at least I'll tell you what to do. Step 1 is find a series for 1 over 1 plus x squared. I'm not going to explain yet why. Only when I did all the steps you'll see why was I doing all this. Okay, series for 1 plus x squared. That is already much more in this form, right? What we have to do here. Typically, there are three things we can do with this basic formula, this geometric series. We can either take derivatives, we can take antiderivatives, or we can do substitution. Which one you think you have to do here? Substitution, right? If I replace x by what? Now think about this. You say x squared, but then you get 1 over 1 minus x squared. It's 1 plus, I need a plus here. So the substitution I'm going to do, so allow me to actually get myself a little bit, I'm going to rewrite, yeah, okay. I can erase, right? That's the fun of this thing. I can erase because it's all on the video, so you can always go back and look at it. Okay, so I'm going to write again my basic series here that I always work with. It's so basic, so it's better to repeat it a couple of times if x is less than 1. Okay, so to get from 1 minus x to 1 plus x squared, I'm going to replace x by minus x squared. I hope you see that, right? If I replace this x by minus x squared, I get exactly this expression. Okay, so when I do this on the left-hand side, I do the same thing on the right-hand side. So what do I get? I'll keep blue, right. So I get 1 over 1 plus x squared, and on the right-hand side, now replace, well, 1, that's just 1, replace this x by minus x squared, replace this x squared by minus x squared, so it's minus x squared squared, the minus sign squared is positive, and x to the 4th. Minus x squared to the power cube, I get a minus x to the power 6. I hope you all see this. If minus x squared is less than 1. Oh, now we have to work this out. Now, absolute values means the minus sign doesn't mean anything. So this is again absolute value of x squared, and I can take square root of everything. So this means if x is less than 1. So right, nothing, it's the same radius of convergence still. Good. Now that's step 1 only. How do I get to the arctangent? You think, oh, I have the x squared ready, but you'll see it's not actually good enough. Now, find a series for arctangent of x. Not arctangent x squared, arctangent of x, just that guy. Okay. What's the relationship between this guy and this guy? Let you think a bit about it. Stop the movie if you want to think a little more about it. If you take the antiderivative of this thing, you actually get this. So what you need to do, I'll do this in another color, is here antiderive. You see, we can do this antideriving or deriving at any point in this strategy, right? So now I want to antiderive, because the antiderivative of 1 over 1 plus x squared is really arctangent. So it's actually that simple. Okay, so we do this. So this, we said, is now going to give arctangent of x. And what do we get on this side? Well, we do the same thing. So antiderive. Right, and here we were antideriving also. Good. Okay, that's easy. It's term by term. Then derivative of 1 is x. Tangent of x squared is x cubed over 3 plus x to the 5th over 5. This is the power rule, right? And do one more. Minus x to the 7th over 7 plus c. Well, I should write dot 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 first, right? Dot 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 plus c. Now, we cannot ignore c. Although often it is 0, it might not be. I should have give you an example of that. In this case, actually, again, it's going to be. So plug in x equals 0. That's the center, right? Because everything is always with the center here, center 0, to determine c. So we don't know yet what c is, and that's why we're doing this. Let's do that. So we have arctangent of 0 equals, and then 0 minus 0 plus 0 plus, blah, 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 plus c. So c is arctangent of 0, so we need to know what arctangent of 0 is. Use a full, try to figure out which angle gives you, for which angle is the tangent 0. You can look at the graph of the function arctangent, you can use your calculator, whatever it is, you'll figure out, I hope, that this is actually 0. The arctangent of 0 is 0. That is because the tangent of 0, which is sine over cosine, is sine of 0 over cosine of 0. That's 0 over 1, that's 0. Okay, so arctangent is 0, so c was again 0. Just, again, I'm telling you, this is not necessarily always the case. But let's move on. So I'm going to, again, now get to the stage that we know that c is 0. And then what's the next step? Well, let's think about the next step. I'm getting close, right? Because I need arctangent x squared, and I have arctangent x. I hope you see now, this is what you need to do. And the deriving, no. It's replace x by x squared. So we're going to do substitution. So the substitution that we're going to do is x replaced by x squared. Then I get arctangent of x squared. Now I do the same here. Replace this x by x squared. And this x squared, I'll have to think about it. X squared to the power 3, that's x to the power 6, multiplying exponents, right? And then this would be x to the power 10 over 5 minus, I have a minus there. Wait, let me see. Did I have my signs correctly? Plus, oh, I wrote this wrong. That was a plus sign, right? I know it was going to alternate. And then, whoa. What am I doing? I'm plugging x squared in x to the 7th with x to the 14th over 7 plus dot dot dot. Now, we have to keep track. Now remember here, when we integrate, nothing changes. That's why I keep forgetting to write it, because it doesn't change, but I should write it if x is less than 1. But when we substitute, things might change. So let's write it up. If x squared is now less than 1, because we replace x by x squared. Now, again, nothing changes, but there are examples where it does, so be careful. And so finally, we find if x is less than 1. So this is the solution. We have a series for that arctangent. Okay, that was 99. Perhaps I want to do another one similar to this, but it was actually already from 6.1. So I'm jumping a little bit, but it's because I told you they spread it out a little bit weirdly. So here I'm going to do this one now here. I'm going back to 6.1, number 40. And the question is actually the same here. We have now 1 over minus 4x squared, and they want, again, centered at 0. Let me not even write that. So they want the power series for this one. Now, as always, we start from our basic formula. Well, let's write down the basic formula. 1 over 1 minus x is 1 plus x squared plus x cubed plus dot dot dot. You might say, why do I need to learn formulas? Everything is going to be open book. Yeah, but you have time pressure and you have to think about things. You don't want to start looking around, wasting 10 minutes just to find a formula. So prepare yourself on the finals. You're going to have to do more than just one problem. And in a kind of, I have still fully decided on the amount of time, but still. It helps to keep writing everything down that you need, because then when you know what it is, when you know the formulas, you know how to use them also much better. Okay, and this is for absolute value of x less than 1. So how do I go from x to 4x squared? You might say, oh, replace x by x squared. Well, let's do it more quickly, because then if I replace x by x squared, I only have x squared. I need 4x squared, right? Be careful, it's not multiplying with anything or anything else. The only things I can do is take derivatives and the derivatives, or substitution. And this is again substitution, and you have to see what kind of substitution is. What I'm going to do is I'm going to replace x by 4x squared. Okay, if you don't see this, so how do you figure this out? Okay, box things. Okay, this is x, and this is now what I need. So box 1 has to become box 2. Okay, this is what I mean. Good, so what do we get? Here we get 1 over 1 minus 4x squared equals, and then there we get 1 plus x becomes 4x squared, x squared becomes 4x squared squared, that is 16x to the fourth, 4x cubed, that is 64x to the power 6 plus dot dot dot, if 4x squared is less than 1. Now this is the one that we have to work on. What does this mean? Well, this means 4 times x squared less than 1, absolute value. We can take square roots of both sides, so I'm taking square roots. I get 2 absolute value of x less than 1. Now remember, to find the radius of convergence, you have to solve for absolute value of x. So finally we have absolute value of x is less than a half, and so this is our radius of convergence. So you see, it can be different. All right. That's that. And then there was this one more homework problem that I assigned that was in the video. So I'll go to that other one that I had already here. Here it is. And I wanted you to write out this product of this series up to degree 6. And the way I did this was very systematically here, right? Try to form all the various powers of x up to 1 we need. Okay. And the way to do is, I'll start in black, I guess. You can take whatever you want, of course, but I prefer to work with the first one and go through the various terms of the first one and see what can I do in the second one to get these guys here. Okay, we start with one, with a constant. How can I make a constant? I have a constant here. Well, this combines with this constant here, and remember, what you do then is take the product of these two constants, so 2. And that's clearly the only thing I can do. Okay, so let's go to power x. Well, I can use this 1 together with this 3x, right? That will give me a power x. So the product of the constant is 6, not 6, 3. But I can also, so there's also this 2x, I can now combine with this 2, so that would be 4. And then this is too high, I cannot do this anymore. Okay, so next. Let's go to x squared. With 1, I can combine this out with this 5x squared, so this is 1 times 5, that's 5. What about 2x? I can combine it with this 3x, right? If I multiply the coefficients, I get a 6. What about 4x squared? If I multiply it with 2, I get 8. X cubed obviously is not going to help me anymore. Okay, I'm going to get rid a little bit of these, things here. So that was an x. That was an x here, right? Okay, and so next, what I do is x cubed, right? So new color, red, x cubed. This one, missing an x cubed here, so that's not going to contribute. Okay, so that I'm going to put 0 there. Then for this guy, it contributes with this one to get an x cubed, right? When you multiply powers, you add exponents, right? And what is the coefficient? Now you multiply the coefficients. That's 10. 4x squared, yep, I can combine with this 3x, and the coefficient is 4 times 3, 12. And then actually this also combines with the 2, so I get coefficient 3 times 2, 6. And that's it. Good. Next one, purple. So x to the 4th. Now I'm looking for a 4th power here, yes, so I get a 6. With this 2, what can I combine here to get x to the 4th? I need an x cubed, right? But there's no x cubed, so that's x is 0. This x squared, together with this x squared, will give me an x to the 4th. Multiplying the coefficients gives me 20, I hope you see where where these numbers come from. Then 3x cubed, I need power 4, so I can use this one. There's always one that you can use, right? At most one. Could be that has coefficient 0, but there's exactly one. Okay, 3 times 3, that's 9. And no, x to the 5, that's not going to get me anywhere, so that's it. End of story. Okay. What do we have still left? Green. X to the 5th. This guy, x to the 5th. Hello. No, x to the 5th, so no, it's not going to give me anything. What about this one? If I combine it with an x to the 4th, I get an x to the 5th. So now multiply the coefficients. 2 times 6, that's 12. X squared. No, I don't have a cube here, right? So nothing. Okay. X cubed. That combines with this square. That's going to give me x to the 5th. And the product of the coefficients is 15. And then x to the 5th, I can multiply with this 2, and I get 2. And that's it, because then we're done. And then x to the 6th, the last one. Do I still, what pretty colors do you want? I'll do brown. That's not a pretty color, but okay. 6 powers. Okay. 1. I have no 6 power. What about this guy? Nothing there either, so no. What about this guy? That combines with this one, right? And so the product of the coefficient would be 4 times 6, 24. This x cubed, if I want a 6 power, I need a cube, but that's not there. Okay, x to the 5th, that combines with this guy. And the product is, so we had a 0 here, so I forgot to write it, and then a 3, and then they're finished. Okay, so now concluding, we need to add all these things in each row here, and this will be the coefficients then. We have a 2 here, we have a 7 here, we have 11, 19, 22, 28, 26, 35, 27, 29, and then 27. So you see these numbers can be real big. Now write down what this means, right? These are, so we really have to combine these two guys, right? So it's 2 times 1 plus 7 times x plus 19 times x squared plus 28 times x cubed plus 35 times x to the 4th plus 29 times x to the 5th plus 27 times x to the 6th. And I hope I didn't make any silly mistakes here, but if so, it would just be a counting error, right? Okay, and that's what you needed to do. Okay, very systematically. You can devise your own system here, but the risk is if you don't systematically, you forget some of these possible combinations. Okay, that's all for the homeworks. Let me see, did I cover this one? Did that? Yep, okay, so that's enough now for homeworks.